All right, see if that's a little better now with sound. I kind of forgot that I didn't have everything set up. Sorry about that. I was trying to get everything set up for you guys tonight and got behind on the 8 ball. So sorry about that. Yeah, so as I was saying, great to be back in Florida. And while we were gone, it seemed like it went from early spring right in the middle of summer. The weather is considerably hotter this week than it was when we left 10 days ago, whatever it was. All right, Rick, yeah, thanks for no sound. Chuck, yeah, thanks for no sound. Dave, thanks for saying it got better. So, yeah, no microphone, you're not going to have any sound. So, yeah, so I was putting together some stuff on for the AC. I wanted to do part 2, which was with AC fittings and hose and lines and stuff. But I was trying to get a lot of stuff done here in the shop too, so kind of ran behind a little bit. But everything's moving along good. Got a couple of different things to show you guys tonight. I was working on the 4-cylinder comp motor, and we ran into an issue with the crankshaft, so I got a little video I put together for that. And got Scott's radiator core support that was rusted out, so that was part of the Olnick engine swap, so I got that. I got a little video for that too. Trying to get some of these other things straightened out here too. So we'll have those to go over too, so we'll do that. Just got a couple more to get here in the right sequence. Try to have everything in order this time. All right, so I think I got that all good. So yeah, so that was the big thing in the shop. We got in town super late Friday morning, and worked on it. Was trying to put the comp motor together, and then ran into an issue with the crankshaft on that. And yeah, Chris, we got to get your AC fixed, and Dave's too. I got to finish making the hard lines on his car, so I'll show you about that stuff here in a minute. So yes, that was on Friday. Then Saturday we worked on the core support. I was able Friday night to get the sheet metal, the 1/8-inch plate press braked, so it was formed pretty much how I needed it to be formed for that. So we'll do a little video on that, and like I said, with the AC, that'll be the final issue here. But yeah, so I guess we'll talk about the crankshaft first, and then we'll go into the AC in a little bit. So if you guys, hopefully you've watched some of my engine assembly videos, and you've seen me when I put the crank in, put a long ratchet on it and ratchet the engine around, and then let the ratchet weight spin the crankshaft, and I check it as many positions as I can check it on. And I've always done that, trying to see if the crank if it's bent, or if there's a high spot or some kind of thing in it. And to be quite truthful, I've only saw one time in all the years doing it that there was a little bit of drag in one certain spot, and on that particular model engine, we checked it, and it ended up being just a thou out around, or bent, so it wasn't even enough that it needed to be fixed. So I wasn't 100% sure how that all would work out. But doing this little 4-cylinder comp engine, it definitely saved my tail, because I had a spot where when I was rotating it, the crank would get really slow, and then it would almost keep going and then kind of stop, and I had to help it along. And then let's say 320 degrees around, it was fine, and then get right back to that spot. And I checked it like 5 times, and actually was in the exact same spot every time. So I knew that we definitely had an issue. Unfortunately, I didn't get video of that. I was trying to get the motor together, and I saw that. I said, "Oh, we got a problem," and let me see what I can do. So we decided to go ahead and stick it in the lathe, which isn't the best way of doing it. V blocks would have been much better, but since I don't have V blocks to do that, we use the lathe. And let me just pull up this video here. Almost there. What I always like to do is let the crank. All right, so here's the video that I pieced together to show the customer his crank, and so he could contact his crankshaft manufacturer to see if this was indeed a fail and if they could be straightened or if it had to be replaced. So here we go. What I always like to do is let the crank free turn by itself, showing that there's no high spots or low spots. Everything, it's nice and smooth. So bottom end is good. Now that was just a snippet from a different engine, and you could see how the crank, the ratchet was gliding through with no issues at all. And I just wanted to put that into the video so they could see what I was checking on. So here's the rest of it. All right, so you've seen me use a long ratchet and spin the crank over with nothing on it, checking to see the drag on the crank. Working on this 4-cylinder, I didn't get the video of it, but I had a high spot that was always there. So I decided to go ahead and put it in the lathe and check it out. So I put a 4-jaw adjustable chuck in the lathe, put the crank in, set my dial indicator up. You can see when it spins. Basically we have 0 movement there. So on that journal, it's centered to the lathe journal, and we have 0 run out. So now we move it to the next one. So we have the dial indicator 0, and we spin it again. And you can see this one's about 5.5 thousandths, 5 thousandths to 5.5 thousandths. We'll go ahead and move it to the next one. Again, we set 0. And now you can see the big swing there, 9.5 thousandths. So now we'll go ahead and take it down to the next one. Now you can see 9.5 thousandths. And we have one more to go. Zero the money. And you can see 9.5 thousandths. Now what I did was I marked where the high spot was and how many thousandths. So it's 9.5 thousandths right there, 9.5 thousandths right there, 9.5 thousandths right there. So they're all 3 are in a line. 5 thousandths on this one, and 0 here. Now, one of the things is we're clamping it by the front and the back of the shaft. So the snout is probably not zeroed in properly. We had the rear one. This one is zeroed in properly. But what should be is we should be on V blocks, and then check them. Put the V block here and here, and then we can check the ends and the middle and everything, and really get a better understanding where we're at. However, I don't have those. And being that this is 0 and the rest is bent, what that really means is this one, and this one are, excuse me, the front one, the second, and the third, those are all 9.5 thousandths. So those literally are the straight ones, because the snout is 9.5 thousandths out of round 2. So that is the way the fixture is on in the lathe. So those three being the same, they're the straight part, and then on this journal and on this journal, the crank is twisted. And of course the bearings show in witness mark that this is the one that's rubbing on the top half front corner and the bottom cap rear quarter. So that's showing it's riding, and it's wobbling in the bearing. It's not riding on the bearing with 100% contact. So we're delaying the assembly of this engine, but we found a problem that potentially could make the engine explode and lose a bunch of expensive race parts. So that's why I always test them with the ratchet, like I show in any of the engine builds, because if I see where there's a drag spot and it continues to do it in the same spot, that usually says that there's something wrong with the crankshaft and alignment. So just an old test that you do by hand. It's really nothing elaborate, but it works. And now we've proven the theory by checking the crank for being out of round. So here's the engine with the bearings. You can see there, no scuffing, a little bit of record player marks from dirt going through, but other than that, they're in good shape. And then we get to the rear one, and get the light in the right spot. You can see that it's got a shiny spot on that leading edge, and there's the cap. The cap looks good until you get to the opposite side, and there's a nice wear pattern there too. So on the cap, on the back side, on the bearing, on the front side. So that was the video. I sent it to the owner of the engine, and he's talking with the crank manufacturer and with the previous engine builder to see what their thoughts were. Obviously, with the wear showing on the rear bearing, it's an issue, and we don't know when the crank became like this, so it could have been at any time. And being it's a fairly lightweight crank, you got the converter hooked to the flex plate on the back of the engine. It's in a drag car, so it's and it doesn't make a killer amount of power. I think this motor makes pretty close to 500 horsepower. That's probably how the deflection in the crank ended up starting anyway. But it's a good thing we found it, and it kind of tells me that my theory on testing the crank, and whenever I was, when I'm building an engine, always let the weight of the ratchet rotate the crank by itself, and then checking the drag as I put each piston rod assembly in the block. Because that way you can feel when the drag changes that there may be an issue. You got to go back and look at it. A bent rod would cause heavy drag, or overlapped ring, or something like that. So it's just a practice that I've always done. For the last, I don't know, probably been doing that at least 30-something years, and not from the beginning, but it was something I started doing in the middle of my business. Or in engine building, and I've just always did it, and always thought, well, if there's a problem, I'm going to catch it. And here we are today. I caught a problem, so it works. But anyway, I'll get you guys some more information when we find out what the outcome is and what the remedy is for that. So now we can go ahead and go back to our AC. Part 2 of the AC tutorial, I guess, or education, where we're show you the different things. So when you order an AC kit, it's gonna come with, typically it'll come with hoses or whatever, you'll have to get them. Rick says, was that the thrust? Was that the thrust bearing? Any sign of dragging on those surfaces? Well, the thrust was tight. Being that the crank is flexed, and we had contact on the block side in the front and the cap side on the rear, that would say that more than likely the thrust flange is following suit to the journal, because it's the journal is way more material than the flanges for the thrust. So yes, when I checked the end plate, so what I was doing with this engine, because we didn't have any notes from the original engine builder. So what I did was I did a forensic disassembly on the motor. I checked basically blueprinted it in reverse. So I blueprinted it as it was coming apart, and then re-blueprinting it as it was going back together, so that we would have a complete package of information for the next rebuild. So the one thing I didn't do is I didn't check the thrust originally, but when I was putting it back together, I did check the thrust, and it was extremely tight. So typically, you want about 4 to 5 thousandths on your end play for the thrust, and this had about 3. So I was kind of tapping the main cap around a little bit, trying to see if I could free it up, and it wouldn't move. And then that's when I started checking the drag, and that's when I found that we had a high spot or a hard spot as the crank was rotating in 360 degrees, and then led us down to putting it in the lathe. And of course, the lathe isn't the most accurate testing. You could see whenever time I put my hand on the chuck, the little bit of quarter thou or half a thou clearance in the spindle bearing on the lathe itself, you could see that in the dial indicator. So again, V-blocks would have been the better way of checking this, but I wanted just to verify that I wasn't crazy and that the drag I was finding was something for real. So but yeah, that's the thing. Now, I didn't really see any scuffing in the thrust bearings themselves, though, Rick. That was they looked pretty good. But again, we don't know when this whole thing started or how many runs were on the engine at this point. So it was a backup engine, or it may have been the original number 1 engine, and they made a backup engine. However, it is the guy that owns the engine. He has 2 engines. One that's in the car right now is the one that holds the national record, and this one's right behind it. So we're just kind of going over things, trying to make sure that he's got a good backup. We'll get the cylinder head back from the cylinder head shop, and then we can put it together, and he'll have a complete engine, so that if there was a problem, he could swap engines and keep on racing. So that's what we were doing with that. So anyway, so on the going to the AC stuff again. So you're going to get, when you buy a universal air conditioning kit, or you have a car with air conditioning and you need to fix it, and you have a hose issue, or you're doing an engine swap, and the hoses, the compressor's in a different position, multiple different reasons why in the hot rodding industry we have to get involved with the air conditioning. So there's 2 kinds of hose. You have, first of all, the AC hoses are all measured by the ID of the hose, not the OD. And these are Galaxy. These are Goodyear. They're U.S. made. And Futura, made by Parker, another U.S. made AC hose. And Continental makes a U.S. made AC hose also. So there's 2 different main kinds of AC hose. You have your standard barrier, which is what is on 99% of the cars on the road. It's those real big, heavy-duty AC hoses. And then you have reduced barrier. And a reduced barrier is a much thinner AC hose. It's a lot more flexible. In fact, the reduced barrier hose, you can bend it and kink it, where the standard barrier, you cannot. Auto manufacturers have gone to reduced barrier, to save weight, just like when we're building a race car. Every time you can take ounces out of the car's overall weight, that adds up at the end of the day when the car is done in being pounds, and could be quite considerable amount of weight with all the different things that they do. So the reduced barrier is what they use a lot of times nowadays. I prefer to use the standard. It's a heavier hose. It will not kink if you have to make a tight bend with it, and it is a little heavier, but definitely way better for leak resistance. And I've always used it. I have some reduced barrier fittings, and I was going to try to play around with them. Probably in the Vet Hawk, I would use the reduced barrier just because, again, weight is going to be a concern. And here's the hose thicknesses. So you can see that the ID is the size of the hose. And then here's the, you can compare the OD from the reduced barrier to the standard. So in a -6 line, it's 5/16 ID, 8 millimeter, both same for both hoses, but the OD is 3/4 on the standard barrier, and it's 19/32 or 15 millimeter for reduced barrier, so significantly smaller. And if you went to a number 12, which most new AC systems don't use 12, but we can use it for comparison. Again, 5/8 ID for number 12, same with the reduced barrier, but the OD of the standard barrier is going to be 1 1/8 inches, so it's considerably large piece of hose, where the reduced barrier is 15/16. So again, you can see where the weight differential will come from, and you can see that the sizes, you can tell pretty quickly which hoses are which. Now, the placements of your AC hoses are going to be, typically you're always going to have an 8 coming from the compressor high side to the condenser. Then your liquid line going from the condenser to dryer or orifice or expansion, the liquids line, that's going to be a -6. And then on most modern AC systems, a 10 would be from the accumulator, evaporator, expansion block back to the compressor on the suction hose. And then your older cars would have a -12. And you can swap those out. It doesn't make really much of a difference. It's just the way they did them back in the day. So here's some working information on the Goodyear Galaxy hose, and you can see, and they give you your IDs, your ODs, your working pressure. So all the hoses except for your -12 is good for 500 psi working pressure, and the -12 is 350 psi working pressure. And then burst pressure, 2,000 on the 6, 8, and 10, and 1750 on the 12. And of course you got a weight per foot. So here's a picture of the layers. So you've got different rubber, neoprene, nylon, and double braided. That's why the hose is so much bigger. But it's also why these hoses will not permeate or typically leak through the actual hose casing, because you've got multiple layers there for good protection. These hoses are always very robust for abrasion. If you got something sharp next to a hose or a motor mount breaks or something, and your hoses start rubbing on stuff, your standard barrier hose should be able to handle that without failing. And if you go to your reduced barrier, you can see that there's a whole layer of braiding and a whole layer of hose support that's missing out of it, and that's how they get the reduced diameter. So your inner 3 pieces, or maybe 4 pieces, are all going to be the same material. You just don't get that extra layer of rubber and extra layer of braiding under the sheath covering. So obviously these hoses, you can they will not withstand abrasion and stuff like that like the other hoses will. So that's something to think about when you're figuring out what hoses you're going to put on your vehicle. The reduced barrier is good for weight reduction and for size, but it may not have the durability that the standard barrier AC hose has. So here's just kind of a jumbo of all different kind of fittings, and there's 3 major AC fittings. I did not get a chance to put the Aeroquip steel braid AC hoses on in this slide show, so that's something we won't talk about today. Maybe we'll bring it up again in another time. But you have a barbed fitting, which uses these ferrules, and then you got bead lock, which the ferrules are built into the hose, and then you've got these easy clip hoses, which are kind of a newer thing, and those are for reduced barrier. All of these fittings can be bought for reduced barrier, so you have to, when you're looking for fittings, you have to make sure you get the proper one, whether it's a standard barrier or reduced barrier. So these are all different kinds of standard crimp hoses. Now these, like I say, standard crimp, you can put either the standard barrier hose or your reduced barrier hose on any of these fittings. You just have to put the proper ferrule that does the compression. But on a barbed fitting, you can see it actually has barbs, just like a fuel barb, a brass barb for your vacuum lines or your fuel lines and all that kind of stuff. So these obviously go together a little harder, but the connection is a much stronger, probably the strongest connection. The other thing about these this style barbed crimp fitting is that these, if you're very careful, you can cut the ferrules off and replace the hose and reuse the fittings, because as long as you don't nick these barbs, they're going to seal when you go together. So then what you have to do is you have to put your ferrule on the hose and you work the barb fitting into it. And you'll see here we have that's a bead lock, not a bead lock, quick connect, like on a Ford product. That is the opposite. That would be the male. This is the female. It's got a little spring in there, and they just click together. It makes it much easier for the manufacturer to assemble the car on the assembly line. And this is a standard O-ring style, where there would be an O-ring in here. And then this isn't a very good picture, but that would be the retainer that the O-ring would seal up against. And then you have a male threaded side with an O-ring that would go into like one of these fittings. And you have flare, which I would not suggest using flare fittings on an AC system, but you can. They used to use them for most of your aftermarket AC kits back in the 80s and earlier would come with flare because it was just easier to deal with. But most everything's O-ring now. And just another picture of your O-ring style male fitting with your barb on there, giving you some dimensions and stuff. And there's some connectors if you want to do a splice. You can do a splice. They also have these with a service port built into the splice, so you can put a service port anywhere in your system where it's easy to get to, so you can hook your gauges up. And these are the ferrules. So you can see that they have a little sight glass. That's to show that the hose is completely to the front of the barb. And when there's a step in the fitting, go back, you see there's a step right there. So when you're fully assembled, the rubber hose should be all the way up against this bump. And when you look in the window of the ferrule, the hose will be completely in that, and then you know you're ready for crimping. And like I said, for standard barrier and reduced barrier, you just have to make sure you get the right ferrule to work properly, because the hose is going to be a different diameter. And these are usually pretty tight to the hose when you're putting them together. So this leads us to our next fitting style, which is beadlock. Now on a beadlock, you can see there's a bump here, and typically this ferrule, you can't see it being separated from there. And the crimping is a different shape of crimping. With the beadlock, we have loops that are going around the fitting, because it doesn't have a barb in the middle of it. It's got some slight shape to it, kind of similar to if this would be the female, it would be the male side in the fitting. But they're pretty smooth. They go together very easily because there's no hard barb to push through, where a barb fitting you have to really work it to get in. These fittings, however, are not reusable because the ferrule is built onto the fitting. So when these go bad, you have to throw the fitting away and replace the fittings. And this is how they come before they're crimped. And you can see the ferrule is built onto the fitting. Still have your sight glass so you can make sure your hose is completely bottomed out in the fitting. And again, these are splices with your service port. And here's different, straights, 45s, 90s, just like everything else. You can get them in all shapes and sizes. So that'll, kind of get you where you need to go for laying out how the AC hoses will fit in the vehicle. I couldn't find a good picture of a beadlock with the fitting off, but needless to say, it's very smooth, very similar to this style fitting. Now, this is what they call an easy crimp. So you have this stainless band that drops into this slot. You have O-rings and very small barbs, and the hose goes over top of all those, and then you use these clips to lock the hose in. And you can see that this retainer has positionings to tell you where the clamps go. Now these require a special plier for doing that. And there you can see the assembly, and here's your retainer, and then the notch for where the clamps go. And this is like a reduced barrier type hose. There's a close-up when it's finished. And these hoses are a little bit more flexible than the normal ones. And then there's your pliers that used to tighten up the clamp. And you can see the clamp has a hook on it. So you tighten it down to where the piece pops over and locks. And these you can rebuild, but you have to cut these clamps apart and then replace the clamps. And you should use these special pliers to do the assembly. And there's just another picture of the support ring on it without the clamps, and then the support ring on with the clamps. You can just kind of see how that goes. And as you can see by the fitting, it's a very small diameter OD hose, so it works out real well for that, for size. Now, when you're laying out your AC stuff, they make these convenient bulkhead fittings. So you can get these in all different 2, 4, inline, square, X's, round, all these different shapes. And most companies you can buy different fittings. So this one would be made for your firewall. So you would have your number 6 liquid line, your number 10 suction hose going back to the compressor, and then these two would be your heater hoses. And they would use a dash 10 specific fitting for heater hoses, and then you use 5/8 heater hoses. Now you can switch, like this 6, you could switch this out to an 8, which is I do a lot of times. I will put this on the inner fender of the car and make short hoses going to the compressor and the engine block, just to get rid of all the hose in the engine bay, and then hide all the hose inside the fender. So a lot of different things you can do with these for cleaning up your engine bay. And then you got different billet styles here, and you can see like this one, 1-6, 3-10. So those would be again, your liquid line going to your evaporator, your suction hose going back to the compressor from your evaporator, and your 2 heater hoses. And again, another shape. This one actually has hose barbs worked on, so you don't have to put fittings on your heater hoses. The other thing you can do to customize your AC installation is you can buy these straight aluminum tubes, and they have them with female, male, flare, O-ring, male, male, female, female, however you want it, in all different lengths. And then you can see like that one's a female to female. So you can make these connections and eliminate rubber hose. So you want to go from your dryer to your evaporator, your condenser. Actually, they make a kit that even hard lines that. So it just cleans up and makes it a much more professional system. See, like here you can, they've used like a piece of welding rod, and then they bought the right length tubing and bent it up to make it fit. So these are just little tricks that I wanted to show you guys to really make your AC installation look really clean. And in fact, you could do this with your heater hoses also, to eliminate large chunks of rubber underneath the hood. These would be much cleaner. You can pin them to the frame and stuff like that. So it just makes it for a much cleaner installation. And just want to make sure you guys were aware that all this kind of stuff is available to you. Now for crimping hoses, you will have to buy a crimper. And I was talking about the standard barbed clamps, barbed fittings with ferrules, and this is the proper tool for that. You can see that this crimps along the length of the hose, and that's the style crimp you want to use when you're using a barb, because that's going to make the hose squeeze down and grab the barbs really well. You can buy these in hydraulic or manual. They usually will come with a rod that comes out the back, so you can mount it to a bench and use an impact gun or a ratchet or whatever you want on that. And you got your different sizes, 6, 8, 10, and 12. There's just another one with the different sizes. You can take these in and out as needed. But this is the style crimper you need for your standard barbed fittings. And again, this is why I wanted to show you this stuff. So if you start buying components and you only have one compressor, then you have to stay with that style fitting. Otherwise, you're going to have to buy a different hose compressor, fitting compressor. So this is for the beadlock style, and this is a master cool. And they have these in different sizes. So a kit that has all these different sizes. So this one has 2, 4, 6, 8, 10, 12 sizes. That's because this is a master kit that will do all beadlock, whether it's a standard barrier hose or a reduced barrier hose. This one has the crimps for doing all of them. There's a much better picture. And again, on the barb, on the beadlock style, it's a different compression, so you can't use these on a barbed fitting, and you can't use a barbed fitting compressor on a beadlock. So just try to make sure when you're ordering your stuff that you know which way you want to go. And again, they do make a benchtop or handheld version of this also, and you can kind of make out the way the fittings are. Again, this is a beadlock, so this one makes the compressions in a circular manner all the way around the hose, where the beadlock, the barbed fittings make them parallel with the hose. So that's the main change there. And of course, there's the plier for the easy fit hoses. So that's the those are the components for installing your AC kit. The only thing that we have left to talk about with AC is Freon and oil. And there are specific Freons and specific oils for that, so maybe we'll get into that at another time. I didn't get a chance to put all that stuff together today. But just wanted to help you guys out. You can use this for reference. If you're going to put an AC kit in your hot rod or do some repairs on your daily or on your hot rod that already has AC, you can look at these fittings and stuff and tell right away which fittings they are. You can look at the hose and they should say the size of the hose unless somebody's wiped all that stuff off. And wanted to let you know about the bulkhead fittings and the bulkhead fittings and the hard lines, so that you could clean up your system as however you wanted to. So, you know, when you're going from on Dave's car, I'm going to go from the receiver dryer is mounted on the condenser. It already has a hard line kit that I purchased with the system, so it's already got a hard line to the dryer. And now I'm making a hard line going from the dryer over to the bulkhead fitting. It's mounted on the inner fender, because all that stuff is stationary in the car. None of it's going to move independently of each other, so we don't need to use a hose. We can use hardline, and now, of course, with the hardline, a lot less chances of any leaks because it's all solid. So another nice thing with the hardline, if you can TIG weld, you can cut the lines and put different pieces together, and change ends and do all kinds of different things, so that you can make your installation easier and do it like that. So that's pretty much anything. I don't know if anybody had any questions on that. I know Chris blew a line on his car when he was moving the engine around, so we're going to have to make a new line on his car. In fact, when we do that, I should I'll show you assembling one of these hoses and stuff. So, Chris, whenever you're ready, let me know. So the other thing that I got done since I got back in town was I was able to get the core support fixed on Scott's truck. I'm getting that engine swap closer to being finished. I'm just waiting on injectors, and I have to finish the fuel injection harness and build exhaust. I did run into one issue when I put the core support on the truck on Monday, is that probably going to have to build a custom fan shroud, because the water pump on the 8100 versus the 366, which, even though they're both tall decks, the 366 probably had a specific water pump, which moved the water pump higher in the chassis, because the engine is mounted in the exact same location, but my fan is about an inch lower than where it should be, so it won't work with the shroud that I have, so I'm going to have to build a shroud for that. But that's not that big of an issue. But let me just bring up, I made a little video of doing the AC, or doing the fan shroud. Let me just find it here for a second, bear with me. Okay, what did I do with the video? Oh, it's an engine swap. Oh, you know what? I don't think I didn't make a final video. Crap. All right, well, we can go through it anyway. So, so here's a unscripted build on the core support. All right, so here's the core support from Scott's C60, and you can see it's got a lot of rust on it. Yeah, ants been eating this thing pretty hard. So we're gonna fix the centerpiece up. This is what mounts the front end of the truck. We'll get this new piece of steel here. Second piece to make these. We're gonna do that now. So I didn't explain on there, but there's two mounting holes down here in the bottom, and there's a rubber block that mounts to the frame. So this mounts to the frame in the center, and then your fenders and inner fenders, wheel wells, bolt to the ends of the radiator support, just like a common car. But I think they did that so that if the frame were to twist, it doesn't necessarily twist all the sheet metal on the vehicle. So just kind of the way like my 50 Chevy was done this way, all the way up into the I know up to 57 passenger cars were still mounted that way. I think once they went to 58, they went to double bushings out on top of the frame rails like the modern cars are. But so anyway, you can see it was rotted out pretty extensively.
And it says finish wear check, and it's a foot and a half up.
So here, I didn't show it, but what I did was I took the plasma cutter and I cut the ends and then bent them down to mimic the shape of the original core support. And this is all out of 1/8" steel. All right, so we got the angles cut, bent these pieces down, and now we're going to weld this up, and this will be the centerpiece for the core support. Well, I explained it there. And of course, I'm just doing some welding here, welding the pieces together. Kind of move through this in a little bit sequence here. I have found a filter I want to use for the camera for getting video on this. I just didn't. It hasn't arrived yet. So, being that this is going to be a truck, and you're not going to see this, I didn't go back and finish all the welds and all that stuff. This is more of a utilitarian build. We're just making the truck we'll run down the road with the new engine, not necessarily trying to make it a show winner. However, when this is all done, none of this will be in an area where you can see it because the radiator sits on top of it, and the bumper and valance and stuff all block it in the front. So here's the piece welded up. That's going to go right here. So now we're ready to cut this section out, put a new piece in there, torch this in, locate it, put it in, and then finish welding. We'll be done. I don't know how, but I didn't get a picture of the plasma cutter. I thought I did, but I missed on that deal. So the piece has already been plasma cut out. Now I'm just taking all the heavy spatter off that the plasma cutter leaves behind so that we can weld the pieces back together.
Productive.
Oh, sorry. So a little bit of grinding action.
Strips or pliers?
Yeah, vice grips. Pass it there. Another set of these. Fitting the piece in, clamping it all together.
Hand plier? Hand plier?
No, just these. radiator support was originally built out of 090, and this is all 125.
There should be some short ones under there.
So just clamping it all in place, getting it all lined up properly.
Productive.
Then I'm going to go ahead and tack it in so it doesn't move.
Okay, so helmet's on grind, not weld. Now we got blinding.
And again, being this is a utilitarian type build where it's really not for show, that's why we went ahead and MIG welded everything rather than TIG welding. TIG welding would have been much cleaner, but a lot slower process, and the material would have to be a lot cleaner. So this is just burning everything in. On the front side, there was a 90-degree bend lip that I left, so that way for extra reinforcement.
Little girl is super cute. the really young one?
Yeah.
Abigail something. Penelope something. Oh, sorry. Go ahead.
That's right. Lily. Like a lily pad. So we got our centerpiece welded in. We got our attachment here. We're going to go ahead and get it marked where we're going to cut it. And that's going to be welded in like that.
So here we're going to go ahead and use the plasma cutter. This time I got it on film. One of the problems I had using the welding helmet in grind position was I was having a hard time seeing the lines to follow them. So it was not my best moment. But I kind of just rushed through it. You can see pretty jagged lines there. Not something I should be proud of by any means. Here I tried a different color marker to try to get a better sight, but it really didn't help. Probably should have just used a pair of sunglasses. It would have been a lot better. And it's out.
Like that. Kind of big fucking hole, but
yeah. So with the
alright, so we got
cutter,
the piece out. We put our new ledge in there, tacked it in place. Now we'll fully weld it, and we'll have the core support all reconstructed.
So yeah, so with the plasma cutter the way it was, kind of big holes in there, but nice thing about MIG welding is you can fill the holes pretty easily. See if we can get that vertical weld on the camera. All right, here we go. You can see with the MIG, you use a little C shape back and forth to keep the puddle fluid and then connect the two pieces of metal together. We'll get the filter. I'll show you more stuff on that.
Hey, got a little bit of gappage here, don't we?
Yeah, that's pretty big.
All right, so there's the piece that we cut out, and here's the repaired piece. It's not all fancy and set up in a press punch and shaped. We had to cut it and weld it and put it together, but this is going to be really strong. It's actually thicker material than what was originally there. And now we just had to drill the holes for the mount to the frame, get some rust reform paint and some black paint and paint it up, and we're ready to install this thing. Once again, this is the piece. So this is what we replaced. So this is the old rusty piece, and there's the new piece. So I thought I took pictures of the final thing. I'll have to go back and look. I'm sure I did, but I did get it all painted up, and I do have it installed in the truck. I didn't get pictures of it installed because I got working on the cooling fan issue and stuff like that. But I'll get some pictures of that tomorrow. I'm going to try to get the radiator installed and so I can start working on AC hoses and stuff like that. But definitely a good repair. You know, for a work truck, it's going to do great. You know, obviously if it was a show car, we would have spent a bunch of time cleaning all the welds up. First of all, I would have welded it with a TIG, so there'd been very little cleanup. But, you know, that was, instead of spending 8 hours on the repair with the MIG welder and the plasma cutter, I was able to do that in about 3 hours. So, you know, save Scott some money on man hours and labor. And we couldn't find one of those core supports anywhere. Obviously, being that the radiator is right above it, that area always held water in there, and so it caused it to rot out. The rest of the core support's pretty solid. Yeah, I got two small holes in the corners to drain, because directly in the center is a big thick rubber bushing. So a hole there's nowhere to drain. But in the corners where it's still flat, I've got two little 3/8 holes, so that should help. But of course that piece was from 1976, so it lasted a pretty good amount of time. I'm sure we're not going to have that truck for that kind of time frame. So that's 50. Almost 50 years, so I think it'll be good. But yeah, I did add some drain holes for it, and hopefully we won't have any radiator leaks, so it should stay pretty dry. But and I did put some rust inhibiting paint on there and coated it with enamel over top of that, so it should be a pretty stout repair for that. So yeah, so that's pretty much what I had for the show tonight. Just getting back in the swing of things here. I'm still got the '69 Corvette. I'm still working on trying to ascertain what the issues are with that thing. I thought it may have had a bad cam lobe in it, but it looks like all the rockers are fully functioning. However, it has comp cam Magnum rockers on it. And to get the chrome valve covers back on, the stock valve covers, they didn't put poly locks on. They used regular the regular rocker nuts, and with the comp rocker, the socket barely fits in there. So I believe that the valve lash was set up incorrectly, because it's almost impossible to get it to make it work right. So that's what I'm working on that, and tomorrow I'll be back up on the Alnick working on, trying to get more pieces done for that, so we can get that straightened out. And also have to do some wheel alignment tutorials for some new employees up at DNR. So that's going to be my day tomorrow, and Thursday we'll be back in the shop working on the T-type. And a buddy of mine came by today and spent about 3.5-4 hours on Dave's Chevelle to figure out the stereo issues with that thing. When we first got everything back from the interior, and I was starting to do our test, we got the radio would work, but it would, with amps and everything else and 6 speakers in the cab, it would barely be over talking level, which it's got a 300 watt amp and stuff in there, so that was not right. And since then it's gone to straight static, and I wasn't sure really where I wanted to, I don't do a lot with stereo, so I kind of was not thinking about how, I didn't have a real good diagnostic plan for that. But my buddy came over, GC, and he installs stereos, and he builds custom Harleys, baggers, and he also does custom stereos in cars and trucks. And so he looked it all over, and there was one spot on the amp you could touch, and it kind of would make some weird noise, so we thought maybe the amp was bad. He brought over another amp, put that in there, still didn't work. So then he took, which was awesome, just like we would for electrical diagnostics, we'd take a voltmeter. Well, he took a cell phone with the headphone plug on one side and RCA jacks on the other side, plugged it into the amp, turned on the music on the phone, and lo and behold, the amp is working clear, pretty loud sound coming out of the speakers in the car. So we verified that all the wiring from the amp to the speakers is good. Then he did the same thing on the subwoofer amp, and same thing, bass worked no problem at all. So the amps are good, wiring to all that stuff is good. So then we moved to the interior of the car, and we tried plugging at that point we couldn't even get any sound out of the stereo at all. So then we used the USB port in the radio, auxiliary input, and again, nothing, no sound coming out at all. And then we switched to the auxiliary in, which is like a headphone jack. So we went headphone to headphone, and again, still couldn't get anything out. Even tried Bluetooth. Bluetooth didn't work. It just seems like the head unit just isn't making any output. In fact, on this particular installation, I have 2 speakers in the top of the dash in the center, which are just coming directly out of the stereo head unit without any amplification or anything, and then everything else, all the other speakers in the car, are going through the amps on a preamp RCA jack. So even just connecting to the two front speakers with no amplifiers or anything installed, still could not get any music coming out. So pretty much confirmed that the head unit was defective, and I really appreciate GC for coming over, because that was I was kind of hung up on what I wanted to do with that and how I was going to try to see. I didn't know if it was gain controls and stuff like that, but hooking up a cell phone to it and playing music through the auxiliary ports showed that was all good. That wasn't any of the issues. So I'm glad we got to that. So we'll get a new head unit for Dave's car and get that all squared away, and get back to road testing that. Just have a couple little things left on that. I got a couple AC lines I got to make, and I have to just do a little bit more tuning in the stereo, and I think we're in good shape with that thing. So we'll get that moving along. So that's about everything we had for this week. Really appreciate everybody coming on and watching. Remember, smash the like buttons. We just going through some of the data from YouTube. I saw that we've just hit 6,000 likes on the videos. So there's 290 videos, I think. So we're working good on that, and our watch hours are good. One of the things when I was going through all the data is, and I don't know how to make this any better, but we're still only about 25% subscribers watching the content. So yeah, again, if you guys aren't subscribed, subscribe. It's free, and you won't get junk mail or nothing like that, but you will get notification when we drop more information. So that it's helpful if you like the content that I put out, and I appreciate everybody coming out and watching, and we'll get some good stuff to go for next week, and we'll see how it all goes. You all have a great week, and see you later. See ya.